Welcome to topic 6 of data science, and this topic is about Python for data science and some of the Python libraries that are used, and also about Jupyterlab, which is the editor that we're going to use in this data science course. So first of all, a little bit of revision. So here is a while loop, and hopefully this is familiar to all of us by now, since we've done a bit of Python before. We have a variable here that we set to 0. Then we got a while loop where we're going to create a condition, and then if the condition's true, we're going to do this one. If the condition's false, we're going to use the alternative here, and the false part of the condition, the alternative, is created by doing else colon and pressing return, and Python automatically indents and uses the white space to separate the logical blocks of code. So hopefully you can see that this will print out the numbers 1 through 5. The one other thing I didn't point out is we've got this variable here working as an accumulator, and each time the loop travels round, okay, we're going to add 1, okay, until the condition is met and the count is no longer less than 5. The count is 5, at which point we're going to break out of the loop, exit and run to the alternative, print this out, and then the computer can stop doing whatever it is that it's been doing. So Python for data science, right? So Python, some people say, and it is true, that Python has overtaken R in popularity among data scientists. So why is this? So Python is a general purpose language. So the keywords are general purpose, and it's used by data scientists and developers. And people choose to use Python because other people can use Python as well. So R is really considered better for statistical packages and statistical analysis. For generating visualizations and stuff, R is there's no question that R is brilliant at that. And R is often used by kind of scientists, medical professionals, social scientists doing analysis. But as kind of newer concepts like deep learning, machine learning, these are things that perhaps R isn't so suited to do. So the general purpose language of Python is more common to use. Now, I've added a link here to a little bit more discussion about this. So there's an article here that just explains some of the main differences between Python and R. But where I find there's actually more value in this discussion is in the comments down at the bottom. So look, there's a side-by-side table comparison here where Python excels, R excels for statistical modeling, Python excels for deep learning research. Okay, so let's go down and have a look at some comments. So this chap comments that R has an ability to create dashboards using Shiny, and that's something that Python doesn't have so easily built. This is an interesting comment. So this guy hires a team of developers, and he said it's very difficult, nearly impossible, to hire R developers. Okay, so if you put a job advert out, you're going to get people that even come from cybersecurity, networking. They're going to have knowledge of Python, but people who know how to develop in R are rarer to find. So some other opinions here. This chap, Holger von Joden, I've probably said that wrong. This guy, Georgie, says use both. The only problem is to find the time to learn both. And then here are my 2 cents on why you should use R instead of Python. So this guy's put a link to a blog here, and he explains why you should use R instead of Python. And then look, 75 people have come in to argue back against this. So basically, the point I'm trying to make is there's a lot of discussion around whether Python or R. So I thought the best thing to do with this course is to have a look at both. Then we're not you know, nailing our colors to any particular flag. So here are some common libraries used in data science. So when I say a library, I just mean a collection of a module is the correct name. A collection of functions and facilities that we can import into Python that aren't there already by default. So Numpy is the first one, and it's a numeric package for Python, and that's what it's called, Numpy. Okay, and it allows you to do to create these things called arrays. It's often called an NP array. Okay, and we can think of this as a sort of more advanced data structure than the basic Python list that we should already be aware of. So here's an example of how we create an array in Numpy. Now, things to note are this up here, this command, all right, is an alias. So import Numpy as NP. That word there, NP, that could be anything. That could be elephant. And then when we called on Numpy, we'd have to type elephant here and elephant here. So, you know, those are just aliases. Now, just by convention, people usually put import Numpy as NP. So then when you refer to Numpy, you just type NP. And I think it's just to save people having to type Numpy out all the time. So when we say np.array, okay, what we're actually saying is we want to use this array function from np, okay, and np is an alias of the library numpy, which we have installed and we're importing into the script using the import statement, okay? And then this syntax here is how we actually draw that array. So it looks kind of similar to a Python list, but we put these round brackets around the square brackets. And then if we print out this variable a in which we've stored this np array, it looks like that, okay? And it has a, then we can do a.d type, and that'll give us the data type, and it's actually an int64 is the data type for the np array. So here's another array created called b, and this one's got float values in it, okay, and we've got these round brackets, and then the data type of that is float64. So a couple of new data types beyond the basic float and integer, okay, and int64 just means it can be 64 bits long. All right, so unlikely that in this course we're going to be using a giant integer that's bigger than that. Okay, so that's how we create an array, and that's one of the most common data structures that you'll see using this Numpy. So the hang on, let's clear that. The next library is called Pandas. Okay, so the Python package Pandas, the main use for this, I don't really want to go into actually reading this out because this is more like a sales pitch than anything. The main use for Pandas is importing CSV files. It is a very powerful library that allows you to work with data. So let's have a look at that in practice. So again, we're importing a library called CSV here. Should be kind of familiar with. And then we import pandas and we just alias pandas to PD, and that just saves us having to type out the word pandas over and over again. Okay, this alias could be anything. Just by convention, we usually import pandas as PD. Then we have a file called, imaginatively, myfile.csv. And then we create a variable, imaginatively called file. And then inside that variable, we're going to run pandas read CSV. So we're going to use the read CSV function from the Pandas library. And then in the brackets of this read CSV function, so in the body of the function, we're going to send in these parameters. First parameter is file name, and file name is myfile.csv. And then we just give it some other options like the delimiter, /t means tab, okay? And then names, okay? We can actually send Pandas these names arguments, column 1, column 2, column 3, all right? Then we can use print, okay? Now we could just print file, but we have this file.groupby, okay? And file.groupby will allow us to print out a particular part of it. So in this case, we're going to count the values in column 3 using the count function there, passing in column 3 after having used the groupby function, okay, on the file variable, and passing that to a variable called summary, and then printing out summary. So a lot of squiggles on the screen there. Let me just clear those off. It looks a bit like someone's drawn all over it with a pencil. So these this is a fairly useful way of importing a file. Now, the standard CSV library isn't quite as clever as Pandas. So using Pandas will allow us to do operations on the columns and rows of a CSV. It already understands how a data structure is laid out. So interestingly, this functionality is already in R by default, right? R already knows columns and rows and stuff already, but because Python's general purpose, right? Python doesn't have this, doesn't understand all of this stuff straight away. So that's why we need to use extra things like Pandas. Okay, so the next library, and this is a very big library, okay, it's called Pyplot. And the real name for Pyplot is Matplotlib Dot Pie Plot. Now, Matplotlib Dot Pie Plot is a difficult thing to keep saying, and even more annoying to keep typing out. So we alias that to PLT. Okay, so PyPlot is always usually aliased to PLT. You could alias it to anything, but that's the convention. Okay, so here we have a really simple example. We have an X and a Y variable. Okay, and then we're going to use Numpy as well. Okay, imported as NP. And Numpy, we're going to use the arrange function from the Numpy module. I'm just going to arrange these values here. Okay, then we're going to do the sin function. Okay, so like a sine wave, which is what I think that is. Terrible drawing. Sorry about that. Undo that one. Get rid of that. And then plt.plot and just passing in these two values will result in this thing coming out. So not very much, just 3 lines of Python. The last one's just the plot and an X and a Y, and that'll give us this. Now, there are literally, I mean, I don't want to say thousands, but like probably, yeah, thousands of examples of graphs and things that we can do with Pyplot. I'll give you a little demo of this when I show you how to get the editor installed. So here's just an example of a simple line graph. So once again, start off importing our 2 libraries, Numpy, Matplotlib Dot Pie Plot. Import that as NP, that as PLT. Create an X and a Y, and then we run these commands just to say what we're going to do with the X and the Y, and then plot.show will give us out this at the end. Now, don't worry, you don't necessarily need to understand how all of, so this is straightforward. This is just 2 variable names, okay? And I would say plot.show is pretty straightforward. So in terms of this stuff here, okay, don't worry too much about understanding what all of that stuff is, because there are lots and lots of documentation that will give you these examples that you can just adapt. Okay, so we don't necessarily need to know the np.sin 4 times np.pi times x, although when you say it out loud, it kind of makes sense. Like pi times 4 times pi times something, okay? But there are lots of examples of this available that I'll show you. So move forward a little bit now to the next example. This one is just a basic pie chart, and we can do this with this code here. So we create some sizes. It just looks like a basic list. Explode just means that we're making, like, this orange one's kind of exploded away from the pie chart. And then we just run some other kind of, you can almost call this boilerplate code, like code that we find that comes with the pie chart. And we can tweak all of these values to generate different types of pie charts. So the next topic, aside from libraries, is Jupyter. And Jupyter isn't really a library, it's more of an editing environment. And the editor that we're going to use in this data science course is called Jupyterlab. Okay, so Jupyterlab. So Jupyterlab lets you work with documents and activities such as Jupyter notebooks. Okay, so what we're going to do in this course going forward is we're going to use something called an Ipython notebook. And an Ipython notebook is really just a big JSON file that has lots of content laid out that we can interpret and we can open with Jupyterlab. Okay, so if we want to open up an Ipython notebook, we're going to run it in Jupyterlab. Now we can also run R in Jupyterlab, and I'm going to give you a little demo of how to do that in just a second. So we need to use a thing called pip. Okay, pip stands for Python install package, or the Python package installer is pip. Now sometimes you need to write pip3. On my computer, for example, I have Python 2. So if I do pip install Jupyterlab, it's going to give me it's going to complain. So I have to say pip3 install Jupyterlab, but hopefully you won't have that issue. So that's how we do it on Linux. But I'm going to give you an example of how to do it on Windows. So here's an example of what a notebook looks like when it's open. It actually runs in a local web server. Okay. And there's an example of a graph running inside. And you can see this abbreviation here. You ever see an IPYNB? That just stands for an Ipython notebook. Okay, IPYNB is an Ipython notebook. So on Windows, what are we going to do? So I'm going to assume that you know how to install Python. In fact, I'm going to demo this right now. So here I have a Windows 10 workstation open. So just to prove this to you, open up CMD, and we'll do, WINVER. So I'm using Microsoft Windows 10, okay, version 2004. Okay, so relatively recently updated. Now, what we're going to do is, if we don't already have Python installed, we just need to go to python.org and click on download Python, okay, and just get the latest version of Python using that installer. Okay, so that installer will run through, and that'll give us two things. It'll give us Python on our machine, and it'll give us idle as well. Now, another thing that it's going to give us is pip. Okay, we should have pip installed. So what we need to do then is open up the command line. Okay, so open up CMD, and we should now be able to type on Windows, okay, pip install Jupyterlab. Okay, pip install Jupyterlab. So if I run that, it's going to give me a bit of the matrix, okay? And you can see here, okay, it's already saying requirement already satisfied. And that's because I've already installed it on this Windows machine. I didn't want this demo to take a long time while we're waiting on my download speed, downloading the file. Now, it's not particularly big. I would estimate around about 70 megabytes or something like that. So If Python's maybe 30 megabytes, this is maybe 70 megabytes. In total, we're talking 100 meg. Okay, so now that we've done that, to launch Jupyterlab, okay, we're just going to type, let me clear the screen. So now that we've got Jupyterlab installed, we're going to type Jupyter Lab and press return. And what this will do is this will start up a local web server, and we should see the startup screen running. And here we go. So now we have, all right, this is Jupyterlab. Now, if you want to, when you first install it, okay, it's going to look like this. Okay, so if you prefer using white on white with dark text, then you can leave it on the light theme, or I find it easier on the eyes to use a dark theme. So now that we have this open and running, okay, we can do we can create ourselves a new notebook. So start off, let's click this. This is the launcher screen. So let's click for a new Python 3 notebook. And what we can do is we can do print, okay, and then open up the print function, say hello there, okay, and then just to run this. Now, this environment here, okay, this thing here is called a cell. All right, this is a cell, this single cell, and it's a code cell. Okay, there's another type of cell I'm going to show you in a minute. So let's clear that. To run the cell, we just do control and return, just like on R. And what that actually does is that sends this command to the Python kernel and returns the value. Okay, so we can have more code in here. Okay, and to run it, we just do control return. It's going to give me an error because more code in here isn't valid Python. Right, now there's another type of cell that we can add. And to do that, we just click on this. Let me just run this again to get rid of that error. There we go. Just click this little plus, and that's going to give us a fresh cell here. Now, if we change the cell type to Markdown, okay, what we can actually do is put a hashtag # and say, hello there, this is a heading. Okay, and then we just press control return, and that's going to give us a heading. All right, now, if we double click, we can edit the cell. We can also do this with H1. Okay, so we can also use HTML tags in here to run, to get a similar effect. All right, so HTML technically is called markup, hypertext markup language. There's H2. And if we were to go down here and do like a new paragraph, and let's say, hello there, I am some documentation. Okay, and then we just close the paragraph. Okay, and then we just go to run this. Okay, this will run, and this will give us documentation. Now, what's really good about this is we can have hundreds of lines of Python code here. Okay, and if we just click on this little blue thing, it'll collapse it down to these wee 3 dots. And there's the output, obviously, hello there. And we can have an explanation of how that code works in the code cell down here. And we can use the markup language if we already know basic HTML. I'm sure most of you do. Or if you want to be a little bit, I guess it's shorter, we can use the markdown language. And I think for a paragraph, we just don't give any arguments, and it will just give us normal text. So let me just run that and show you what the result would be. So there you go, kind of similar, although that's not a heading as we know it. Maybe I need to do a space there. There we go. Okay, so that's the markdown syntax, and obviously I showed you the markup syntax. Okay, so those are the two types of cells that we're most likely to. We've got the code cell, and we've got the markdown markup cell, depending on which way you want to look at it. So that's how we get this environment running on Windows. Now, the labs for this subject, I'm going to give you are going to be in the form of an IPYNB notebook. Okay, so to open the lab, what you're going to have to do is have this environment installed, and then over here in your file manager, right, the lab, you should put the lab in this folder, and then you should just be able to double click on it and it'll open and you'll see the notebook file. Okay, now the good thing about this is once you're, let's say you worked on a project and you developed a load of code, you can do a couple of things. You can export this as a PDF, okay, or as an HTML file. And there's a few other options in here. I'm not sure what ASCII doc and restructured text are. So that would allow it to be a printable version. Like I would allow someone to read it. However, if you download, what you're going to do is you're going to download the notebook file, okay, just like the file I'm going to give you. And then the person who opens the file will be able to see all the code and all the markdown. So it's a useful way of sharing documentation, okay? If you think, if I sent you a Python script that had a load of comments in it, let's say hundreds of lines of comments, those are going to be quite difficult to read. You're going to have to scroll through the Python script. So this is a useful way of having sections of code and sections of documentation together in the same file in an easy to read and easy to run way. Okay, so what I'm going to do is I'm going to kill this virtual machine, this Windows virtual machine. So let's just do suspend. And I'm going to start up Jupyterlab on my local machine. So it's exactly the same way on Linux as it is on Windows. I think you can just do Jupyter space lab, but for some reason I'm in the habit of doing Jupyter minus lab. I'll give that a wee second to run in the background. My computer's probably quite upset because I'm killing this virtual machine. So those are the Windows instructions, and I've put them on this slide here. Let me just tidy this up a wee bit so we can see what this looks like. Let's just move that there. Okay, now there was someone in the other class getting an error, and the error was Jupyter is not recognized as an internal or external or operable program. And for some reason, the command Python -m notebook got them to the same place. So you may have to try that command as well. So I said I was going to give you some demos of some of these libraries. So let me just go back to the first one, which was Pyplot. Okay, so Pyplot, very heavily documented. So let me just grab their web page and let's have a look at this. So we're looking at an old version. Let's go to the new version. All right, so this is an absolutely huge library here. So let's go to the examples page. Now, here are all the examples. And if you can just about see inside there, look how many there are. Literally, like, my computer can't even load how many examples there are. Literally thousands of different visualizations and how you do these with this library. So let's scroll down and say we want to make this bar chart with gradients. Okay. Does not support gradients, so maybe that's not a good idea then. Let's not play with that just now. So let's go for a simple plot. We want to do something more fun than a simple plot. Let's go for, okay, this looks pretty fun. Color mesh grids. So what we can actually do, all right, is if we scroll down, it usually gives us an example that we can download, or we can just, you run the code that's here. Okay, so interestingly, you might notice that we have two things that we can download. We can download a notebook, or we can download the source code. So let's download the Jupyter notebook for this. Hopefully it'll work if I click on it. I mean, oh, here we go. Okay, I probably shouldn't have clicked on it like 5 times there. So let's click. And what I'm going to do is I'm going to save this in my code folder. Okay, so in code, I'm going to save PC color mesh grids.ipnyb. Right. Now, Jupyter should have opened. It'll be somewhere. Here's Jupyter opening up here. Okay, so let's just rerun this, refresh it, and get it to open up. When this very first loads up, it's going to ask me to select a kernel. So let's just say no kernel just now. And let me just do, I've got simple mode on. Let's do file, new, launcher. Okay, so this is a launcher screen here. Now, you might notice I've got some other kernels installed, not just Python. So for example, if I click on an R kernel, it's going to give me a blank R notebook. So if I were to do X is the same as the values of 2, 4, put some numbers in there, okay, and then we do plot X. Okay, so we should know this from our R studies that's how we get an R plot. So let me do control return to run this. Let's just see what happens. It might probably take a wee second to load. Now tell me that's valid R. That is valid R, I'm sure of it. Error, network when trying to fetch resource. Oh, don't worry about that. Okay, so this should be running as R. I don't know why it's not. Ah, there we go. Okay, there we go. So there's a plot in R there. That's just to show you that we have R running in this Python notebook. Okay, right. So what I'm going to do is just do new, okay, notebook, and I'm going to go for Python 3. And we're back to where we were before, except I'm just running this on my local machine. Now, what I downloaded, okay, in my code folder was this PC Color Memes notebook from the Pie Plot website. So let's open that and look at this. We've got a whole nicely laid out notebook file with references and with documentation and with examples. So let's try running one of these and see what happens. So let's try running that. Let's try running that. And I think we can run this, run the selected cells and advance. And you see what it's doing is it's advancing down. Look at that. That's generated, this code here has generated that. So if we keep advancing down the notebook, there's another example. Let's run this. Look at that. There's another example. There's how you do that in Python. Okay, let's keep running this down. So the lab that I've given you is a notebook file, and you open it up in Jupyterlab. Here it is here. You just double click on it. And here's the lab here, Data Science, Python Programming, Lab 5, Notebook 1. Okay, and what we want to do, test you can see the file first. So there's a file this week called caps.csv. So let's test and see if the file exists, okay? Now, I've written, because it's for you, path/caps.csv. So obviously that's not going to work. Let me run it. Okay, you can see here it's saying false, and that's because that path doesn't exist. Okay, so what you need to do is download a file called, where are we? CSVs, caps.csv. So I think if I were to copy the path from here, copy path, and then put the path into here. Okay, and then I'll just prepend on their home. So home Michael code, data science labs, CSVs, caps.csv. Let me run that, and it should, underneath the cell now, come up true. Yes, look at that, true. So now we can see the CSV file, okay, which is over here, because we've told where the, now this path will be different for you on your computer, okay? Obviously, C:/this PC/John/. Now, check if you can print out the CSV file. So let's run this code cell. Okay, so we're getting errors, and the errors are because I don't have the path in there. Okay, then print out the continent with the most capitals. So I'll show you what caps CSV looks like. Jupyter can open CSV files. It looks like this, okay? We have Let's change the delimiter to a space. Can we do that? Look at that. So it's a simple file. We have in column A, we have countries. In column B, we have capitals. In column C, we have continents. Okay, so for example, Antarctica doesn't have a capital and it's in the content. It's a terrible example. Okay, let's look for, Canada. Capital is Ottawa, and apparently it's in Central America. Well, that's a mistake, but let's worry about that another day. Okay, so Denmark, Copenhagen, Europe. Okay, so what we want to do for this lab, all right, is do some searching of this CSV. And to do that, all we're going to do is write some code in here and run it, and the code will print out here. So we just need to put in 3 Python examples to complete this lab today. So I'm going to stop sharing my screen now. I feel like that's enough of a demo. Find out if anyone has any questions. We'll stop the recording as well, because that's probably quite a lot of information I've just passed on there. So let's just do pause recording.